Hello all, I'm Sid, and today I'll be talking about enzyme-linked immunosorbent assays, also known as ELISAs. So, what is an ELISA? An ELISA is an immunoassay often used to quantify how much of a specific analyte is present within a sample. For ELISAs, some of the samples often used include serum, plasma, cell lysates, and saliva, among several other things. And furthermore, for ELISAs, there are four main types. There's the direct ELISA, the indirect ELISA, the sandwich ELISA, and the competitive ELISA. We will primarily be talking about the first three in this video. So now I'll be talking about what a direct ELISA is, and I'll also be mentioning the roles antibodies and antigens play in its performance. So a direct ELISA is the quickest ELISA to perform of the four previously mentioned. It is typically used to measure the immune response to an antigen as it is suitable for qualitative and quantitative antigen detection in samples of interest as well as antibody screening and epitope mapping. For how it works, with the direct ELISA, the antigen of interest is immobilized directly onto the surface of a multi-well microtiter plate. After that, enzyme-labeled primary antibodies specific for the antigen are added to the wells. Following incubation, the excess antibody solution is washed off, leaving only the enzyme antibodies bound to the antigen. Substrate is then added, which upon reaction with the enzyme will produce a colorimetric reaction that can be measured by a spectrophotometer or absorbance microplate reader. Ultimately, the stronger the color change, the higher the concentration of antibody in the sample. So, before I continue, I should mention what one of the biggest disadvantages with the direct ELISA method is, and it's that antigen immobilization methods are not specific. What this means is that, for example, when serum is used as a source of antigen, all proteins in the serum may stick to the microtiter plate well. This means that the small concentrations of antigen in the serum need to compete with the other serum proteins when binding to the well surface. This issue can be resolved with a sandwich or indirect ELISA, which uses a secondary antibody or a capture antibody specific to the antigen to pull it out of the serum's molecular mixture. I'll be describing these in the next few slides. Okay, so for the indirect ELISA, the antigen is immobilized onto the wall, like in a direct ELISA. However, there is an additional step. First, an unconjugated primary detection antibody is used to bind the antigen of interest. Then, a conjugated secondary antibody is used to bind to the primary antibody. The conjugated secondary antibody reacts with the substrate to produce a colorimetric signal that can be measured. This greatly increases test specificity for the antigen of interest and helps avoid the disadvantage of the direct ELISA. For the sandwich ELISA, the capture antibody is coated onto the microplate. When a sample is added, it binds to the antigen of interest and immobilizes it onto the plate. After, a conjugated detection antibody is used, which binds to an additional epitope on the target protein. Substrate is then added, and a signal proportional to the amount of analyte present in the sample is produced. Overall, sandwich ELISAs are very specific since two antibodies are required to bind to the protein of interest. Effectively, both the sandwich and indirect ELISAs improve test specificity compared to the direct ELISA. The main way through which they do this is by incorporating additional antibodies. By including more antibodies, they incorporate more ways to bind the antigen, immobilize it, and to amplify detection. For instance, in the indirect ELISA, sensitivity is increased because more than one labeled secondary antibody can bind to a primary antibody, which is something that can greatly amplify a signal. For the sandwich ELISA, there are additional antibodies already embedded in the well that can bind to an antigen and hold it in place. After this, enzyme-conjugated antibodies are used to bind to the antigen as well. This matching of antibody pairs is highly specific and sensitive. Thus, when greater specificity and sensitivity is wanted, it may be worth looking to either of these ELISA methods in place of a direct ELISA. Thank you for listening, and these are the sources that I used.